Hello and welcome to Focus Hour Calculus. Today we'll be discussing integrating complex trigonometric functions. Specifically, we'll be focusing on sine and cosine, and rather than focusing on more specific formulas like square root of a squared minus x squared formulas, we'll be focusing more specifically on sine and cosine, secant and tangent. So if we're ready, let's begin. So, before we even begin, there's a few specific formulas from other trigonometric subjects from pre-calculus or algebra 2 that you might have to remember. And here's a few. Sine squared x plus cosine squared x is equal to 1. You'll also have to know that sine squared x is equal to 1 minus cosine 2x over 2. You also have to know cosine squared x is equal to 1 plus cosine 2x over 2. Of course, you'll also have to know a lot of other trig functions and trig formulas, but we'll get into that as we're doing problems rather than considering all of them right now. However, before we even begin, we also have to consider something called even and odd. So I'm going to assume that you understand even functions and odd functions. Let's do a little review. Let me write this down. And as of now, even functions are currently just those with a degree that is even, and odd functions are those with a degree that is odd. We'll get into more specifics later, but when that is applied to trigonometric functions, that is just what we are assuming right now. So, with these formulas, let's get into a question rather than questioning the formulas. So, very basic formula, very basic question here. That's going to be the integral, my bad, of sine squared x. So, first things first, we have to understand the degree is even. So, because sine is squared, the degree is even. And that's just the rule with trigonometric functions. And after that, because the rule is even, and just relate that to the fact that we are understanding this topic for the first time, therefore there's a few rules that just should go without explanation, you just use the identities. What are the identities? It's exactly what we're talking about with the formulas. Use these formulas in order to solve this question. So let's try that. As of now, we understand that sine squared is equal to this function. So in this case, still in the integral, we're able to know that this entire integral, sine squared, is equal to 1 minus cosine 2x over 2. We can even simplify that to be 1/2 the integral of 1 minus cosine 2x dx just by moving the 1/2 out the equation. So it was moved out, as you can see, with the 1/2 being outside. So after all of that, how do we solve? So, as we understand through the last few videos or through pre-current videos, integral rules come in a few different ways. First and foremost, we can simply separate it and do it separately. As we see with the 1, the integral of 1 would become x. So 1/2 x minus 1/2 the integral of cosine 2x. So what is the integral of cosine 2x? That would be equal to 1/2 x minus 1/2 times 1/2 sine 2x. And we can also just continue to simplify a bit just to get the most satisfactory answer. 1/2 x minus 1/4 sine 2x plus c. Don't forget the plus c. I did ignore it through the last two functions we were doing, but please don't ignore it at the end. It's very crucial nonetheless. And that's your answer. Okay, so when a degree is even, as you can see right here, the answer is pretty simple. So what about if a degree is odd? What happens then? Well, let's try it. So the question then becomes the integral of sine cubed x dx. What happens then? So we understand that a function is odd. So in this case, you just have to separate the function. And what do I mean by this? I mean you simply have to make it even. So in this case, it would just be the integral of sine of x times sine squared x. It's exactly the same thing. The only thing you did was separate it in order for you to then apply the identity. But this time we're going to do a different identity. So let's go back to the formulas. Last time we did this formula. As you can see, this time let's try the other formula. Let's try this one. Seeing as sine x squared plus cosine x squared is equal to 1, we simply have to move this over here, and that'll get us our formula. So in this case, let's move back to our question. Sine times 1 minus cosine squared x dx would be the exact same thing. Now for that, we can simply u sub it. Do a u substitution. As of now, our u is equal to cosine x. And therefore, our du is equal to negative sine x. Now just place it back in. Question would be negative here because we just placed the negative and replaced it. 1 minus u squared. After that, we can just remove it from this set equation. Remove the integration. So now we have 1 over 3 u cubed minus u plus c. And after that, we can replace the u back. So 1 over 3 cosine cubed x minus cosine x plus c. And that's your answer. Alright, so we understand even and odd. Given that, let's do a more complicated problem. Now, this problem is not only something you'll see on an advanced calculus test, but it's something that is more interesting and more rigorous so that you'll be ready for any problem. So in this case, let's do the integral of sine to the 5th x cosine to the 4th x. Now you can do it, but as of now, if you really just want to watch and learn, since we already did the basic problems and you can, I'll do the rest. So that would be equal to the integral of sine x. Remember, when you have an odd, as you see right here, you separate, and therefore you separate it into sine x multiplied by sine to the 4th. I didn't do that step, but it should be understood. And then you separate, as you understand, we are able to apply the identity, which is that right here. Sine squared x is equal to 1 minus cosine squared x. So at that, we understand that here it should be 1 minus cosine squared x. That would represent sine squared. And then that's squared to represent sine to the 4th x. After that, multiplied by cosine the 4th x. That is our first step. And then after that, we're going to just simplify it. Sine x, and then seeing as this is squared right here, let's just square it. Let's put those and distribute it. So this would be equal to, let me just put this all in white, cosine to the 4th x minus 2 cosine to the 6th plus cosine to the 8th. And after that, dx. So once again, we not only paired that in, but we also added this one into the equation just to make it more simple than ever. Now, after that, what is the next step? And I want you to think long and hard about this because it could be more easy than you think. It's very long right now, but it's actually a single step away from being solved. You just have to u sub it. So, u substitution. What is u? U is equal to cosine x. which makes derivative of u is equal to negative sine x, which is exactly what we see here. So the answer would just have to be equal to negative right here, it's crucial, u to the 4th minus 2u to the 6th plus u to the 8th du. That would simply be equal to taking it out of the integral. I'll do it on the bottom just so you see it clear. 1 negative, I didn't forget that, negative 1 over 5 cosine to the 5th x plus 2 over 7 cosine to the 7th x minus 1 over 9 cosine to the 9th x. And don't forget the plus c. That is very, very crucial and the easiest mistake to make. And that's your answer. Box it in, and you have that answer.